Okay, so we're nearing the end of our identities unit. We're going to learn about double and half angle identities. These are our last identities that we'll talk about. We will have one more lesson on how to prove double angle identities, but then that will be it. Okay, so let's take a look at double angle identities. So here are our three different kinds. You'll notice that cosine actually has three of them that you can use. And it doesn't matter which one you choose, just try to pick the one that makes the most sense for you and makes it the easiest. Sometimes it doesn't really matter, but you should get the same answer no matter what. Okay, so this first problem says if cosine of theta is equal to negative 7/25 and theta is between pi and 3 pi over 2, then find tangent of 2 theta. So once again, I'm going to use one of these to help me, and it says find tangent of 2 theta. There's only one to pick from, so I'm going to use that. Before I do that, you'll notice in the problem here I have to find what tangent theta is, and I don't have that information. I only have that cosine of theta is negative 7/25. So this means you will need to draw yourself a triangle and use that information to help you out. So we are in quadrant 3 here, based on this information, and cosine is negative 7/25. So if this is theta, then this is 7 adjacent over hypotenuse, and one of these has to be negative. That means since the radius has to be negative and we're in quadrant 3, that x has to be negative. You should be able to do a little math to get your other side here. That will also be negative because we're in quadrant 3, and that would be negative 24. Okay, so now let's take a look. I'm going to zoom in a little bit here so we have, so if I want tangent of theta for the formula, let's take a look at our picture here. Tangent would be opposite over adjacent, so negative 24 over negative 7, or basically 24/7. All right, so now if we look back here at this formula, I have 2 times tangent of theta over 1 minus tangent squared theta. So that's, maybe keep this on here so you can see that. Let's go to a different color here. All right, so now we're going to figure this out. It's 2 times tangent of theta. We just said tangent of theta was 24/7. And then we're going to go 1 minus tangent squared of theta. Tangent squared. So make sure that's squared. And we're just going to simplify this, and kind of the pre-calculus part of this is over with. You're really now just working with fractions and doing some simplifying. So here we go. On the top we would have 48/7, and on the bottom we would have 1 minus 24 squared over 7 squared. So that's 576 over 49. All right. So let's go up here. We need to subtract these two, so I'm going to change 1 to 49/49. So we have a common denominator. And then simplify the bottom. So the bottom would be 49 minus 576 would give me negative 527 over 49. Okay, so then I'm just going to multiply by the reciprocal. All right. And now, oh, that should be 49 on the bottom there, which would make this 49 right there. Okay, so 48 times 49 gives me, well, it's going to be negative first, 2,352. And then on the bottom, if we multiply that, we get 3,689. Okay, so now simplify that. So again, if you have to use your calculator to do that, we get negative 336 over 527 is the reduced value. And there we go. So again, it's kind of just starting with using your triangle, figuring out what you need, and then using one of the double angle identities. Okay, let's try another one. All right, so I wanted to do another one that you have cosine involved, just because there's 3 and it seems kind of weird. So we're given tangent. So in this case, I'm going to start with my picture again, because I need sine or cosine or both of them to use one of these cosine identities here. And so I'm going to need a triangle again. Let's see, before I draw my triangle, that's not the right one. We want to be in quadrant 2. Okay, so now tangent is opposite over adjacent. So opposite over adjacent, and this is the one that would be negative then. Do a little math here, Pythagorean theorem, to get your hypotenuse. You should get 29. Okay, now you can pick any of these 3 that I have boxed here for cosine, and it shouldn't really matter. You're going to get the same thing anyways. I'm going to use the middle one just because it only has sine, and then I only have one of those values to use, but it doesn't really matter. So in this case, if I'm going to use that one, I need to know what sine of theta is. Sine would be opposite over hypotenuse, so 20 over 29. Okay, now I'm just going to use that formula up there. It says 1 minus 2 times sine squared theta. So that means 20 over 29 squared. So I just have to simplify this and then I'm done. Okay, so be sure you stick with PEMDAS here. So that means I got to do my exponents first. So it'll be 400 over 29 squared is 841. Okay, now before I can subtract, I got to multiply. So I have 400 times 2, which would give me 800 over 841. Now remember, I want to have a common denominator, so 1 is going to be 841 over 841 minus 800 over 841. This would give me 41 over 841. You want to see if you can reduce that. That is already reduced. So again, a lot of just working with fractions, but start by drawing a picture, usually a triangle that you will need, but not always will you need the triangle. Sometimes you can get away with it if you have the right information, but in both of these problems we didn't. Okay, hopefully that makes sense on how to use double angle identities.